am Noor AMIRA, and in this video, me and my groupmate will explain in details on experiment 7, estimation of heat capacity and entropy generation, which is an open-ended experiment. Our group consists of MOHAMAD FIZRI, NASREEN AINA, NOOR ALAZIM, NOORDIN, and me myself, Noor AMIRA. Without further ado, starting with the objective. So the objective of this experiment is first to estimate the heat capacity of different metals provided. Next is to estimate the entropy generated when these metals are dropped in a container containing water.
Hello, my name is Noor ALAZIM. So today I'll be explaining about the theory for experiment 7, which is the estimation of heat capacity and entropy generation. So we move for the heat capacity, which is heat capacity is the amount of heat required to raise 1 degree Celsius of body temperature. So when the two bodies with different temperature exchange heat, the amount of heat lost by the warmer body equal to amount of heat gained by the cooler body, and intermediate equilibrium temperature is attained. This is true as if this experiment is doing in the closed system, which is no heat loss to the environment. Then a heat solid of known mass m and temperature is dropped into a calorimeter containing cold water of known mass, which is M2. After that, the temperature at equilibrium has been reached is determined. The solid heat loss must be equivalent to water's heat gain. So this is the temperature, the formula we use in the experiment, which is heat loss by the solid equal to M is mass of the solid times Cp is heat capacity of the solid, and times T2 solid minus T1 solid, which is initial and final temperature for T1 is initial and T2 is final temperature. Then the second one is heat gained by the water, which is M2 is mass of the water, Cp is heat capacity of the water, times T2 minus T1 water. So if this at equilibrium, T2 is equal to T2 solid is equal to T2 water. The heat capacity for water in this experiment we use is 4.187 kilojoule per kg Kelvin. Then we move to the second one is a system or environment entropy change can be negative, but total entropy generation is always positive. The increase of entropy principle as generation must be more than zero required, and a process to move in a certain way. The magnitude of irreversible present during the process are measured by the entropy generation. This process generate entropy, which is calculated as follows. The formula is delta S with generation equal to MCP ln T2 over T1. Then the second one is delta S total equal to delta S metal plus delta S water. That's all.
Hi, Assalamualaikum warahmatullahi wabarakatuh. I'm Noordiana, and I'll be proceeding with the apparatus and procedure of this experiment. So for the apparatus, we need metal string, aluminum foil, thermometer, 3 different type of blocks which are iron, aluminum and copper, water, 2 beakers, hot plate, and lastly a weighing scale. Next, for the experimental procedure, first the metal needs to be weighted using the weighing scale. The weights for each metal needs to be recorded. 100 ml of water was filled in the first beaker, and the water was heated by using the hot plate. Next, the metal string was attached with the copper block. The copper block was put inside the beaker that was filled with water until it was fully submerged. Let the copper block be inside the water until the temperature reached 80 degrees Celsius. Assume the temperature of metal is equivalent with temperature of water. And then the second beaker was also filled with 100 milliliter of water, and the initial temperature of water was measured. Next, the copper was transferred from the hot water to the second beaker, and aluminium foil was used to cover the second beaker in order to minimize the heat losses to surrounding. Next, the temperature in the second beaker was recorded for every time interval as in table given until the constant temperature was reached. The experiment was repeated by using aluminium and iron block. That's all from me. Thank you.
And my name is AINA, and I would like to explain about calculation of this experiment. So in this experiment, the mass of water given is 0.1 kg, which is 100 gram. The specific heat of water at 25 degrees Celsius is 4.187 kJ per kilogram Kelvin. Okay, in this is the data given by our lecturer, where the initial temperature of three metals, which is copper, aluminum and iron, is 80 degrees Celsius. Meanwhile, the initial temperature of water is 25 degrees for three types of metal. The equilibrium temperature is 32 for copper, 31 for aluminium and 33 for iron. So to calculate the specific of metal, we have come up to a conclusion where heat loss of the metal is equal to the heat gain by the water, which we can have the formula of mass metal times with specific heat of metal multiplied by delta T of metal equal to the mass of water, specific heat capacity of water times with delta T of water. By using this formula, we can obtain the heat capacity of metal as a subject. For copper, we have obtained the specific heat is 0.52958 kJ per kilogram Kelvin, while aluminium we get 1.35633 kJ per kilogram Kelvin, and for iron we get 0.64496 kJ per kilogram. The theoretical specific heat capacity of metal at 25 degrees Celsius is given, which where copper is 0.385, aluminium is 0.9 and iron is 0.44. Based on this theoretical specific heat, we can calculate the accuracy of this specific heat capacity calculated. For the entropy changes, we use the formula of delta S, which is kilojoule per kilogram, is equal to the mass of metal multiple with heat capacity of metal multiple with ln T2 over T1, where T is in Kelvin. Okay, for copper, we get entropy is negative 0.00892 kJ per kilogram. And the entropy changes of water is 0.00972 kJ per kilogram. Therefore, the total entropy generated would be 0.080, where we sum up the entropy changes by the metal and the entropy changes by the water. The same formula used for aluminium and copper and iron. Where for aluminium the entropy changes is negative 0.0766 and the entropy changes for water is 0.834. And the total entropy generated would be 0.00066 kJ per kilogram. And for iron, the entropy changes calculated is negative 0.01018 kJ per kilogram, and the exchanges of water will be 0.01109 kJ per kilogram. Therefore, the total entropy generated is 0.0091 kJ per kilogram. This data is calculated and we put it back in the table of result. That's it for me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is FIZRI ISMAIL, and today I'll be explaining about the discussion part for the last experiment. Okay, we are needed to compare our estimated heat capacity with literature or existing data. Okay, we have find the CP for all three metal during the calculation part. Okay, to find the percentage error, the formula given is modulus CP experimental minus by CP theoretical close bracket of modulus divided by CP experimental times 100. Okay, for the percentage error of copper, we gain the value of 27.30%, which we gain the CP experimental of 0.52958 minus by CP theoretical 0.385 divided by CP experimental, and hence we get 27.30%. For percentage error of aluminium, we gain the value of 33.64%, higher than copper percentage error. Okay, same as before, the formula 1.35633 minus by 0.9 enclosed by modulus divided by 1.35633 times 100, and we get 33.64%. Okay, lastly, for percentage error of iron, still the same formula, and we get 31.16% by 0.64496 minus by 0.44 enclosed by bracket of modulus divided by CP experimental of iron just now, and hence we get the value. Okay, for the next part, we are needed to plot a bar chart of CP that we gained earlier for the calculation part. Okay, as you can see, iron have the value of 0.64496, and for the aluminium part, the green indicator show that we get 1.35633, almost 1.4. And lastly, for the copper part, the blue line, we get an amount of 0.52958. Okay, we move on to the next part of the discussion. Discuss about the total entropy generated during the above process. Total entropy of a system can only be either increased or remain constant in any process and never decrease in value. Note that if there is no net change in entropy, the process is reversible. If the entropy change increase, this shows that the irreversible process. Nevertheless, since we obtain positive value for entropy change from our calculation, it shows that there are some errors occurred as we suppose should obtain no net change in entropy, as the process itself is reversible. Okay, how do we know that it is reversible? It is reversible as thermal equilibrium between water and metal will occur. Hence, both water and metal will have the same temperature and the metal can be heated again. Hence, the process can be repeated over and over again. Okay, next, sources of error and method to minimize the error. Okay, first sources of error, parallax error. Error while taking measurement, such as the temperature of thermometer. Okay, next, volume of water may not be accurate as no measuring cylinder is used during the process. Next, the beaker is not isolated, which result in heat loss to the surrounding. Okay, how can we minimize the error? Okay, first of all, for the first error, we can minimize it by ensure our eye level is perpendicular with the scale before taking measurement. Next, using a measuring cylinder to measure 100 ml of water before transferring it to a beaker. And lastly, ensure the beaker is isolated. Okay, next part of the discussion. Justification on the importance of stirring the water in the container. While the beaker is submerged in the water, it is compulsory to keep stirring the water during every significant second to ensure the heat from the metal is evenly transferred throughout the water in the beaker, hence improving efficiency of heat transfer while minimizing the error occurred. Okay, next, justification on the importance of transfer the hot metal quickly into the water. Okay, the heated metal earlier has higher temperature compared to the air surrounding as soon as it is taken out from the beaker. Hence, heat transfer will occur to reach thermal equilibrium since there are two bodies in contact with each other and can freely exchange energy, which in this case we want to avoid as it might affect our result later. Ergo, by transferring the hot metal quickly into the water, we can minimize heat energy loss to the surrounding, which will result in a more accurate value to be obtained. Okay, we have reached the last part of the discussion. Is it important to know the heat capacity of a material and entropy generated from the heat transfer process? If yes, why? Okay, we have concluded that it is a yes. Since heat capacity can be defined as a measure of the amount of heat energy required to change the temperature of 1 kilogram of a material by 1 Kelvin, therefore, it is important as an indication of how much energy is needed to cool and heat an object by a given mass and amount. While by knowing entropy generation, we get to know either the process is reversible or vice versa. Besides, entropy generation cannot be negative and may only be increased or stay the same. As we have stated earlier just now, there is no net change if the process is reversible, while for irreversible, the entropy generated value will always increase. Hence, by knowing entropy generation, we get to know is the process reversible or the process is irreversible. Okay, I think that's all from me. Moving on to the next presenter. Thank you.
In conclusion, the heat capacity of the three metals and the entropy generated when these metals are dropped in a container containing heated water can be obtained by using calorimetric method. The percentage error is yielded by comparing experimental and theoretical heat capacity values. The percentage error for copper is 27.3%, aluminium is 33.64%, and iron is 31.16%. This experiment might be having some errors and inaccuracy due to the apparatus used, which is a water container that causes major heat loss to the surroundings. In future, this experiment can be improved by using a proper insulated calorimeter for accurate values. That's all from us. Thank you.